Welcome back to VTU e-Shikshana program on computer aided engineering drawing. Last session we studied about the rectangular lamina which is having longer edge and smaller edge, and we had the problems on the shatter edge on HP and the lamina inclined to HP, and the edge on HP is inclined some degree to HP. Now I will show what exactly we have done in the previous session. First, the lamina is on HP, then we made it inclined to HP, keeping one of the edge, shorter edge particularly on HP, and then we gave inclination to the VP for the short edge. Either you can take towards VP or away from VP. This is towards observer or away from VP. And also we have second problem with longer edge on HP, the lamina inclined to HP, and the longer edge on HP is inclined at some degree to VP. These two problems we have worked out last session. Now let me take up the reverse of this problem. What exactly the problem is? Now you can say the lamina is on VP. Now instead of HP, the lamina will be on VP. The shatter edge will be on VP and lamina inclined at some degree to VP. This is what we are going to study now. First position, second position. Third position is the edge on VP is inclined at some degree to HP. Everything is reversed now. HP becomes VP, becomes HP. So the angle you can change, no problem. But in this, let me take the angle of inclination to the VP as 45 degree and the edge on HP inclined at some degree to HP. So rectangular lamina 60 mm by 40 mm has a smaller edge on HP or smaller side on VP. The lamina is inclined at 45 degree to VP. Draw the projections. When the side on HP is inclined at 30 degree to VP. Actually it is not HP. Side on VP is inclined at 30 degree to HP. So this is what the problem is. Okay. Now let me demonstrate the same. Rectangular lamina of 60 mm by 40 mm has a small side on VP. Yes, let me have like this and give inclination to the VP by 45 degree. Then side on VP, the side on VP is actually perpendicular to HP right now. Okay. Now he says it is inclined at 30 degree to HP like this. Better you take always towards XY line. Even you can do this. Alternate solution is there. First position, second position, third position. Okay, only AD must consider and then give inclination to HP, none other than AD. Okay, I will explain that clearly by solving in change of position method. Now let me draw rectangle. Okay, rectangle. Always maintain some gap between XY line and the lamina. Assume that I am keeping this. Draw rectangle. Okay, dark the same. Then name it properly. A dash, B dash, C dash, D dash. Observe carefully. This is the direction of vision. Left extreme nearest corner is this, A. Next visible point is this. If you look from top, you can see only AB, not CD. So visible corners first. The two start from left extreme nearest corner, then visible point, then C, then D. Since it is front view, I have noted with prime or dash, A dash, B dash, C dash. Next you project. Since we are having the lamina on VP itself, you have to project on XY line. Now the projection will be like this. Okay. Now name this as A, B, not visible these 2 points, CD. Now we have projected it and got the top view. Why not below XY line? Because this is on VP. Definitely it will be on XY. Whatever you do here for VP, it is on VP and the lamina is above HP at some distance. That distance you will not worry. Convenient distance you can take. Next, what we do is we try to rotate this about AD. For that purpose only we made it perpendicular. This is edge condition with respect to VP. The lamina inclined to VP, the edge on VP. So naturally the AD, either you can take BC, VC as reference and then give inclination to the lamina. But always you prefer AD because space management is easier in this case. Now let me take this AD. Now give inclination to what? VP by 45 degree. Assume that this is 45 degree and the distance is 60 mm. You take compass and do it manually. Computer, you move and rotate. I will explain that in the computer software. Now, angle of inclination is actually this is phi. You need not write phi unless it is straight line problem. You can directly write 45. This is covered now. Now, dark this portion. This is actually front top view when it is inclined, when the lamina inclined to VP. Now name these points B, C. How to get the front view? Second figure, front view. So you try to draw right extreme projection and then topmost projection. You should not cross these lines with using manual drawing. In case of computer, you use alignment indicator. Definitely you will get, you touch this point, move, again you touch this, you will get the point. Then this point is B dash. This is A dash. Here you have C dash and D dash. So these are the corners. So absolutely this is apparent shape of certain area. Now we have executed 2 stages now. First stage is we have kept it on VP and then we made the smaller edge that is to be placed on with perpendicular to HP. We rotate about that. Then we are supposed to keep AD inclined at some degree to HP. That's all. Okay. Now how to do it? See, this is first position, second position, third position. You can take AD always nearer to XY line. Even you can do that, but once you do it, you should have space management, you should take well away from that and then draw it. Otherwise it will overlap. Better you take always nearer to XY line. AD nearer to A dash nearer to XY line. So you should take A dash D dash only for that particular inclination, none other than this. Okay, you can take BC because it is parallel, but you have to identify AD nearer to XY line. So draw a line inclined at 30 degree. In case of manual drawing, you have to draw. Otherwise, in computer, you can directly take and then give inclination to this 30 degree. I will show you in computer software how exactly you can execute it. Now, the problem is first position, second position, third position. That's all. This is final position. So, how to redraw it? In computer, you move and rotate about AD, A dash, D dash. But here, manually, what you have to do is you have to take this. This is true length. Here also it possesses true length. Here also this is true length. No change because it is on VP. So this is true length line. Okay. Now draw perpendiculars and then take this distance D dash and mark. Okay. Now take this figure into consideration and name properly. This is A dash, this is D dash, A dash D dash is inclined 30 degree, then this one is B dash C dash. Now dark this because this is final front view. This is final front view. Next comes the final top view. How exactly you draw the final top view? Here also it must be very carefully done by having minimum number of lines. Draw extreme right and the lowermost projection from BC. Beyond it you should not cross unnecessary lines, and also you should take care of AD. Where is AD? AD is on XY line. Unnecessarily don't project. This is A, this is D. Similarly, already we got C by the intersection of projection from previous top view and the third front view, C dash. This is C, this one is B. So highlight these points for your purpose, then join them. Join accordingly A, B, C, D. So this comes the final top view front view. AD is on VP. AD is inclined at 30 degree to HP. Here only you can explain. AD is on VP and inclined at 30 degree. It is a problem on straight line. A line is 30 degree to HP and on VP. So this is how we can solve the problem on the lamina which is inclined to VP. For this also I will try to explain that in brief using computer software. So I will explain the problem which I have worked out already with the computer software. So let me repeat the problem. The rectangular lamina of 60 mm by 40 mm size has a smaller side on VP such that the lamina is inclined at 45 degree to VP. Draw the projections when the edge on VP is inclined at 30 degree to HP. Edge and side are same. Okay. So now what I will given, lamina is inclined to VP by 45 degree and one of the short edge on VP and is inclined at 30 degree to HP. So it is the edge condition with respect to VP, because the surface inclined to 45 degree, we have to make it parallel to VP so that you will get the true shape on VP. Front view is true shape. Okay. Now the edge condition is shattered edge on VP. The edge to be placed on VP is always perpendicular to HP in the first figure front view. That's what we have discussed. Now before going to the actual problem, let me take this figure. It's very easy to understand. A rectangular lamina of 60 mm by 40 mm is on VP with one of its longer sides 30 mm above HP. Okay. So this is a simple problem on lamina, say. You can observe this particular lamina is having longer side parallel to HP and the shorter side is perpendicular to HP. But what do we want in this case? We want AD. AD actually must be perpendicular to HP, so that we can rotate about AD so that we get the inclination to the VP at a given angle. So the starting figure is this. This is the initial position for us. Okay, this you need not worry whether 30 mm or 15 mm, as per the availability you take 1 or 2 centimeters and start. Now let me go for the first figure. You know how to draw it. Now the problem is drawing rectangle. How to draw rectangle? Okay, so the rectangle I will repeat here only. How to draw rectangle? Already I have shown you. Okay, rectangle by 2 points. Okay, rectangle by 2 points. You can have start from any point. Then the blue color refers to the longer side for us. Now it is 60 and the blue color for vertical line is 40. Try to see that it is correct. Okay. Sometimes it may vary, you check again. Now the smart dimensioning you take and then work out whether it is correct or not. Check whether it is correct or not. Here kept blank for that. Now you take nominal normally. Now this is 60, this is 40. That is how you can create. So this is the way you create the triangle. I have done it already for you. Now A dash, B dash, C dash, T dash should be named properly. This should be the starting point because visible points are AB from the top. CD are not visible. Visible points first you have to mark A dash, B dash, then C and D. Now you just observe in sequence. I have visible point A and B in top view and CD in bracket. And since the lamina is on VP, as I explained already, this is to be placed on XY line. Now the next item is you have to, so this is how you do it, and then finally you check for the angle of inclination. Okay. So this is how you get 45 degrees. If there is any change, you can change it. Now next you have to project it and get it. So how exactly you project it? Then try to project these two extreme lines, then project this, not beyond this line. These are stoppers now for us. Again from this you stop at this point. Then this is A dash, B dash, C dash, D dash. Okay. So get that A dash, B dash, C dash and dark the front view. So what we have done so far, we made it placed on VP with one edge perpendicular to HP, the two smaller edge, because on that we have to rest the lamina on VP. Then we made the inclination to VP by 45 degree. Now what we have to do is A dash, D dash right now is perpendicular to HP. So whenever I address XY line, that is perpendicular to XY, that means perpendicular to HP. Okay, since it is two lines, I can say directly perpendicular to HP. Next, you redraw this figure, second figure top view, front view, such that A dash, D dash is inclined at 30 degree. You can take above or below. Better you take the one which is in anti-clockwise direction. Better. And keep that A dash, D dash 30 degree. You cannot give 30 degree to A dash, B dash. It is wrong because that is the line which is longer edge and also it is inclined to VP already. Okay, you cannot give inclination. You have to give inclination to AD only. For that purpose only we have made it perpendicular to HP and about that we have rotated. Why I am repeating? Because many times the A dash, B dash or D dash, C dash will be given 30 degree. It is wrong solution. Now how to do it? I will show you how to do it here. Move and rotate. Okay, first you take this move command, and move to suitable position, above or below, not necessarily exactly same position. You can take same height, you can take any suitable height and do it. So here just disappeared. See that should be made shaded. Okay, the move with original position there only, and also you want extra one. So after doing that you will get this one and then rotate. So here only I can do it. Now I will give some idea about that again. Move. See that this is dark. Move it. Yes. Now you rotate. How to rotate? Again you take the rotate command. Then about A, you rotate this figure, and I am actually 30 degree to HP. So horizontal line geometrically. Then I am rotating about vertical line. So you have to give 60 so that it assumes 30 degree. Now check. You need not take first 30 degree line you draw and then do it. Directly you can do it. See, I will measure this. I will measure this and then it assumes 30 degree. Suppose there is change, you can change, but carefully you do it. But once it is already named and fixed, there will be some random changes. Take care of that. Then how to do the next procedure is get the final front view. So how to get the final front view? Project A dash, D dash only on to XY line because they are on VP, and B dash, C dash to this locus. Project this BC and then get it. See, this is how you project using construction line 0.13 and get the points. Okay, A, B, C, D. Yes. So I got A, B, C, D points. Then join accordingly A, B, C, D, D, A. Then you get this one. So the lamina is completely resting on VP. The front view is true shape. Then the lamina is going to assume 45 degree with VP. Whatever you do here, that is for VP. Then you get apparent shape. After getting apparent shape, AD is perpendicular right now, but I don't want AD perpendicular, I want 30 degree because it says the edge on VP is inclined at 30 degree to HP. So definitely you must give inclination to the HP, then you get final top view. So this is how you complete a problem on lamina with the inclination to VP. Then we will try to discuss the problems on triangle, pentagon, etc., square, all those things. Okay. Now I will again give one solve one problem on whiteboard, then come back to computer software. Now I will utilize the same diagram which I have on the whiteboard and explain some typical problems which can be asked. And the concept is the the rectangular lamina is given as the basic plane, and they may ask you to draw the projections. They never give the inclination, but they give front view, apparent shape they give. So exactly they can give. Let me write a rectangular lamina of 60 mm by 40 mm as a smaller side and HP they never give. They say appears as a square in front view. Appears as a square in front view. Draw the projections. So that's all they give. They never give anything. They never say it rests on VP, etc. So you can analyze the problem. Suppose that rectangular lamina of 60 mm by 40 mm appears as a square in front view means, see, you can observe here, in this particular case, I have 40 mm shorter edge and 60 mm longer edge. Suppose that I keep like this. It is on VP, say, it's on VP. It is true shape. Now, you give inclination to the VP, then only you get apparent shape in front view. Okay, in front view. Let me normalize this situation. Let us not worry about the inclination to the side, etc. In second position, you get square. So, what must be the initial position? Initial position must be short edge only. Then only you will get, if you rotate, 60 mm becomes 40 for a particular angle of inclination. Suppose that you keep it like this, then all the time you get rectangle. If you do it for 90 degree, you will get line, but you never get any square. So you must conclude that the shorter edge must be on VP or parallel to VP so that you can rotate, okay, and get the figure, side view. So I can even add, when the side on VP is inclined at 30 degree to HP means, you need not give side is on HP as a data. You have to assume, see, if it is on VP, then only you will get on VP inclined 30 degree. Even otherwise, if this is not given, simply if they say the side is inclined at 30 degree to HP, you could have taken away from it and then rotate. So, first position, second position, third position. We will try to work out these problems in future. At the same time, I will give one more idea about the what is called square, and then it appears as rectangle. Same type, same concept. The square is on VP, say, or away from VP, parallel to it. Then rotate, you will get rectangle. So this is constant, say 40 mm square, this is 40 mm. This may become 15 or 20 or whatever. They may give a square appears as 40 mm by 20 mm. They need not give the original size also. It is 40 is understood. 40 is constant. This is 20 or 30 or 25. So first position, second position. So we will try to work these problems on computer software. Okay, both the rectangle appears as square and square appears as rectangle. Okay.